Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at vectors. So vectors are quantities that have both magnitude and direction, as opposed to scalars that have magnitude only. So the quintessential example is speed versus velocity. When you calculate the speed of an object, you're calculating just how fast it's traveling, but when you calculate the velocity of an object, you're calculating not only how fast the object is traveling, but in which direction it is traveling. Speed is a scalar quantity, velocity is a vector quantity. Velocity can be negative. It just means by the negative that it's going in the opposite direction. So we draw vectors like this as lines with an arrow at the end. The arrow indicates the direction. So we usually call vectors something like U, and we write those vectors with a little arrow on top. So this vector here has the same magnitude and direction as this one. So we say that these two vectors are equal. So I'm going to call this U as well. See, it doesn't matter that these two vectors start from different points, that they're located at a different place in space. We don't really care about that. All we care about in a vector is its magnitude and direction. So these two vectors are equal. Now this vector here, it has the same magnitude as the first two, but its direction is exactly the opposite. So we would call this vector negative U. The negative simply means it is going in the exact opposite direction. Now, when we're adding vectors, we use the head to toe rule. So I have two vectors here, V and W. So to add vectors, we line them up so that the head of the first vector, where the arrow is at the toe of the second vector. So when you add two vectors, you get another vector. V plus W is just another vector. So when you're adding two vectors, you always go from the toe of the first vector to the head of the second vector. So this here is the vector V plus W, and we put an arrow to indicate it's a vector. Now, if I wanted to add R and S here, we have a little problem because their two heads coincide. We need to, before we add the vectors, make sure that the head of the first vector is at the toe of the second vector. So R plus S and S plus R are exactly the same. It doesn't matter the order in which you write them. So what we can do is we can either move R or move S. So I'm just going to choose to move S. So remember, when it comes to a vector, we only care about its magnitude and direction, not from where it starts. So I could draw S so it starts here. As long as it has the same magnitude or length and is going in the same direction, this vector here will also be equal to S. So now that I have head to toe, I can easily draw R plus S. It'll be the vector that goes from the toe of R up to the head of S. So this will be the vector R plus S. Once again, put the little arrow on top to indicate it's a vector. All right, let's now look quickly at the parallelogram rule. So the parallelogram rule arises when you have two vectors like this that emanate from the same point. So I couldn't add U and V as they are because the head of one vector is not at the toe of the other. So I could either move U or V. It doesn't matter which one because U plus V is the same as V plus U. So I could move U over here. As long as it has the same magnitude and direction, this vector will be the same as the original. I also could have put V over here. As long as it has the same magnitude and direction as the original, these two vectors are equal. It doesn't matter about their position. And this has formed a parallelogram. So U plus V, I can start here, and I will get from the toe of the first vector to the head of the second vector. If I'm doing U plus V this way, this is their sum in green. If I do V plus U this way, this is their sum in green. So when you have two vectors that emanate from the same point as they do here, their sum is enclosed by a parallelogram, this being the parallelogram here. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.